Okay. Hello everyone. This is Team 27, and we are making this video to introduce our project for the capsule design 2020. And the project we did is a hierarchical detection system for violent behavior based on deep learning. So our team have 5 members, and I'm running Hao, and the other is Jin, Hele, Sichao, and Donglin. And our advisor is Professor Yuan. So the reason why we want to do this project comes from a data that we noticed on the internet that in the United States there are more than 7 people per hour die of violent deaths, and more than 19,500 people were victims of homicide, and over 47,000 people died by suicide in 2017 alone, and that's just for 2017 1 year. So this is a really horrible problem, and not just in the United States, but also happened all over the world. So, and what makes the truth even more sad is that plenty of these violent behaviors will happen just in front of a camera. So that means we we had a chance to do something for the victims. We may have the chance to save them, but we couldn't because we cannot ask someone to staring at the screen of the camera 24 hours and 7 days a week. It just cannot happen. And here comes our question. What if the camera can watch over the screen for us? What if when the violent behavior happens, the camera itself can alarm the man in charge so that whoever get this alarm uh, can take the action to save the victim. That's what we want to do in our system. So, and our work assignment will be divided into four parts. And Dolingao will do the data pre-processing work. And I'm going to do the violent detection model training. And Jin will do the crowd density model training. And Hale and Sichao will doing the system establishing.
Yeah, it's only there continue to introduce. Our original thought is that we like to build a wireless behavior detection system using our deep learning methods. This structure you can see is E. Then we would like to distinguish the wireless behavior with or without to grade its level to enhance our system. Please. We attempted several times, but the results are not very good since the data set of the wireless behavior with weapon we find is hard to find, and the one we find quality cannot support us to adjust. So we do a little change. With original design, we decided to use crowd density instead of weapon detection. So there's our project design. It's included 3 parts. The first is violent behavior detection model training, and crowd density model training, and then judgment system.
Subsystem 1 is the training of the violent behavior detection model. For the dataset, we have 2,000 video clips with or without violent behavior. They are suspected to one training set of 1,600 video clips and another testing set of 400 clips. As for the pre-process on the datasets, we first transform the video tape data to a matrix. Here, the number 16 denotes 16 timestamps. Double 112 means the width and height of the video image. 3 means the 3 channels of color, red, green, and blue. The next step is to compute the mean of the dataset for synchronization. To enlarge the dataset, we then zoom and tailor the video data. As for the deep learning model, we set the C3D model for dataset training. First, Xavier initializer is used for initialization, and I2 loss function is used for regularization. Then, softmax for classification function, cross-entropy function for loss definition. Also, we use Adam optimization algorithm to set two learning rates as amount of change to the model during each step. The one is 0.001, relatively big, and another one is relatively small. Okay, the subsystem 1 is done.
The second subsystem is about crowd density evaluation. So we used a dataset. It's a 716 street image dataset with pedestrian labeled. Among the datasets, 400 are used for training the model and 316 for testing. We also do some pre-processing for the dataset. For example, we zoom the image a little bit to transform them into a smaller size so that the training can be faster. And we also do some tailoring to focus on the areas that has pedestrian. The model we used for this part is a classic CNN model, which has 3 convolution layers and 2 fully connected layers. So that's totally 5 hidden layers. We use the image as the input, and the prediction output has 2 parts, a density map and a global count. So the loss function is also the combination of density loss and cost loss.
So we've already talked about every detail of our detection system. Let's make an overall summary of the process. Firstly, when we input a video sample, the subsystem 1 will make a judgment whether it exists violent behavior. If the answer is no, it will skip the rest steps and set the alarm level as 0, which means it's a safe situation. If yes, it will intercept several frames from the video and send them to our second subsystem. In this part, it decides which emergency level of this video is based on the crowd density. For example, if these frame samples show there are 2 or 3 people engaged in violent behavior, maybe the level will be 1 and the corresponding information is mild situation. With the crowd density increases, the level will upgrade. In the end, after these 2 judgments, our system will alarm the person in charge. So that's our whole presentation, and thank you for listening.